Hi there, Mike McLean for RC Video Magazine. The first story in this issue is a visit to a special club in northern New Jersey. If flying model planes is supposed to be fun, then this club is the perfect example. Let's go to the top of New Jersey. This summer, the RC Video Magazine crew was warmly welcomed by the Top of New Jersey Club and spent a day with the members doing what they enjoy most, flying RC aircraft. We started the morning at Lake Musconetcong, flying float planes until lunch. The rest of the day, we were entertained at one of two airfields that are maintained by the club. The Top of New Jersey Club is in the northwest corner of New Jersey. This 150-member club has fun in a variety of non-competitive family-oriented activities. Twice a year, they sponsor a fun float fly. The club also has two family picnics and a large Christmas party. Sunday mornings, this club gathers at the water's edge to fly float planes. A friendly group, we could tell right away. These guys enjoy themselves most when it's time to get their floats wet. A beautiful place to fly. It's not entirely without hazards. The lake is quite shallow, and in many places rocks are exposed waiting for the unwary pilot. But the folks in this group know exactly where the rocks are, and they simply go between them. This is Bob Graham with his 2-year-old Sea-Cat built from a Berkeley kit. Bob is a past president of the Top of New Jersey Club and flies many forms of RC aircraft. His Sea-Cat appears to be a very successful float plane and seems to handle the breeze nicely. Sooner or later, every plane gets a little too wet. Bob quickly retrieves his plane. He punctures small holes in the wing bays, squeezes the excess water out, and in a few moments, he restarts his Sea-Cat. And is back in the air. The club has been in existence for more than 25 years. Some of the original members say the club was begun as the Sussex County Unified Modelers, or SCUM. When the club incorporated, they changed the name to the Top of New Jersey. Now the wind has picked up and Bob Kircher is going to brave the waves with his ugly stick. Bob and his father manufacture foam core floats. Their company is called Kircher RC. Bob Boswell built this North Star from a Balsa USA kit. It is a high-performance Delta Wing aircraft that flies as well over water as over land. This is Rudy Roloff's SIG 1/4 scale J3 Cub. Always a great float plane project. Rudy has powered his Cub with an OS 120. Every year, the top of New Jersey puts on fun float flies in June and October. The location is the State Park on the shore of New Jersey's largest lake, Lake Opacticon. This could be a great way to open and close the float flying season. If you'd like more information on these events, contact the Top of New Jersey Club. Now we're going to look at Jack Squire's Phantom 90, created from a Balsa USA kit. Jack covered his plane with aircraft Dacron and painted it with polyurethane. Power is supplied by a Maloney 125 two-stroke engine. The Phantom also flies on floats or wheels. Jack is the one who acquired the use of this lakefront property, available to the club on Sunday mornings. Of course, you still have to have a rescue boat, and this is brought in by Tom Copy. Rudy Roloff shows up every Sunday with his boat motor. By working together, this club has the perfect float flying setup every Sunday, all summer long. The next aircraft we're going to see is a scratch-built PBY. It took best of show at the 1987 Rams and third in military scale at Toledo. Using Sid Morgan plans, Bob Boswell constructed this 9-foot wingspan Catalina. The primary building materials are balsa and plywood. Twin K&B 61 engines supply power with 18-ounce independent fuel systems. The sponsons are activated with 2 Futaba retract servos. Covered with SIG coverall and Dan Parson fiberglass, the Catalina is painted with hobby epoxy paint, providing the military color formula. Bob tells us that it came out 3 pounds heavier than he would have liked. Total liftoff weight, 21 pounds. After returning the Catalina, Bob wanted to get one more flight in with his North Star. As it seems to happen so many times, when getting in that last flight, while we were looking the other way, the North Star met its demise.
Bill, what happened?
What happened? I came around in a real steep bank turn, and as I came around, it just kept getting a little more inverted and a little more inverted. And as it was heading down, I pulled back a little, and it just went straight in.
Back a little. Aren't you supposed to push forward a little?
I goofed. I admit it.
A few miles away on New Jersey state land is the club's main airfield.
Hey, we're talking with Larry DeRubo, president of Tapa New Jersey Club in northern New Jersey. Larry, what kind of club is this?
Well, basically, we're a sport club. We do a little bit of everything. We've got some pattern flyers, patterned electrics to helicopters. A few of us are flying with quarter scale and even some ducted fans around. With 150 members, you cover about the whole gambit. Primarily it's sport-type ships. Any day of the year you find us out here, weather permitting, from morning till night, flying from sticks to trainers to mild pattern airplanes. Some of the folks are even into full scale, and we've do some overflying every now and then. Club is growing. It's getting very popular. When I joined, 8 years ago, we had 61 members. Now we're pushing 150. We've got about 40 applicants waiting to get in. What we try and do is accommodate everybody. At some point in time, I imagine we'll get saturated. We do maintain a second field north of here, and some activity goes on there, but it's not quite as large as this one. This particular field is state property. We've been here about 10, 11 years now. We expect to be here a while longer, but it's scheduled to become a reservoir at some point in time. So we're starting to look for a new field, and in doing so, we worry about everything else: space, development. It's going on in northern New Jersey. Noise is starting to become an issue, and there's some grassroots work going on in the club to deal with the noise issue. Pretty much we're left alone. There are no neighbors around. We're open to the public. People come in. We're open to other flyers. We just ask that people come in, identify themselves, and abide by our rules, and have a good time with us.
One thing we all have in common is the fun and enjoyment we get from our hobby. Looking closer, you may find many areas of interest, from fine scale to pylon racing, helicopters, gyrocopters, slope soaring, electric, and good old Sunday afternoon sport flying. It's a long list, and new RC flying machines appear each year. No matter how skilled we become in one, it's still good to know what's going on in other areas of RC modeling. You never know. You might learn something new you can apply to your own projects. This video magazine is modular, which means you can watch a segment, then skip over those that don't interest you. And later, while you're waiting for the epoxy to set, take a look at the segments you skipped the first time. You may not want to build a pylon racer or electric scale, but you may find yourself entertained. Our next story takes us to Downey, California, and the K&B manufacturing plant. K&B has been making model airplane and boat engines for 44 years. From there, we're going to Doug Pratt's workshop for another Sport Flyers Corner. K&B offers an economy line of sport engines for the model aircraft and marine hobbyist. By using all American-made materials and manufacturing many of the engine components themselves, K&B has maintained a high standard of engine quality at an affordable price. Shooting on location in Downey, California, we will show you some of their operations and manufacturing techniques. High-quality steel bar stock is machined and turned into blank crankshafts. The computer-controlled mill takes the crank blank held in the eccentric collet and turns it into a precision crank pin. Other crankshafts for the 20 and 40 size engines have crank pins of specially hardened steel that are pressed in. We'll be viewing some of that operation later. This machine is called the vertical CNC mill with automatic tool changer. It performs all of the necessary operations to finish the 20 and 40 size engine crankshaft blanks into completed cranks, including pressing in the crank pin and grinding.
What could you see?
The liquid you see is a special coolant to keep the metal parts from overheating. The key cutter puts the counterbalance in the crank. The large porthole at the back of the crank is drilled with the coolant turned off to get a better view. After this, a counterbalance hole is reamed, followed by reaming of the crank pin hole. In the next step, this CNC mill does the polishing, facing, and turning of the outside diameter of the cylinder heads. Here is a before and after view. This huge CNC mill performs numerous functions on 3 different engine parts. In the front row of the parts tray, there are 6 crankcases. The middle row is set up with muffler adapters, while the back row has cylinders. This machine taps 24 holes in the crankcases, then bores and faces the inside surface of the crankcase. Not all of the parts at K&B are made on computerized equipment. Many parts are manually assembled or drilled on presses such as these carburetor assemblies.
Excuse me, what do you call this operation? Excuse me, what do you call this operation?
I call this. Don't ask me what I like to do. Go talk to him. He'll tell you all about it.
What does she call this operation?
I'm tapping the hole. That's what it is. I'm tapping the hole.
Oh, if she's tapping the holes.
Otherwise, I'm threading this hole.
Okay, it's hole threading. What part is it? What's the name of the part? You've been doing it for 5 years. What is it?
No.
Pardon?
No, not for 5 years. This is a low-speed disc. This is what this is.
Okay. She's tapping the holes of the low-speed disc. Doo-dah, doo-dah.
Here, the metal retaining rings on the bearings are removed and replaced with plastic rings because the plastic is more durable and does not fall apart and damage the engines. Here, the final assembly takes place. Years of experience with model engines enable these people to detect any flaws, looking for just the right feel when the engine is turned over before it is passed on for rear plate and packaging. K&B has devoted a considerable amount of time and money using computer numeric control mills to build more accurate parts with closer production tolerances. They always are designing new machines to upgrade their manufacturing capabilities. K&B is proud of its long history in building model engines and inventories 250,000 parts in an effort to bring to the modeler an affordable and accessible model engine. We went to Lakewood, California to visit Larry Wolf, owner of Jet Hangar Hobbies. Larry has been producing ducted fan and jet aircraft since 1975. Larry Wolf is a master-scale builder and has built and flown model aircraft for several motion pictures, including Iron Eagle and Iron Eagle II. The reason for our visit to Jet Hangar Hobbies is to learn more about the latest kit, the F-4 Phantom. This single-engine jet features scale inlets and bifurcated tuned pipe and outlets. This 1/10 scale jet has a wingspan of 44 inches and weighs 10 pounds, ready for takeoff. Powered with Turbax 3 ducted fan and an OS-65 VRDF engine. This model, built by Dorian Anderson, is ready for takeoff roll. But before we get airborne, we're going to the Jet Hangar Workshop in Lakewood, where Larry Wolf is going to show us a little more about what makes the F-4 tick.
What we've tried to achieve on this airplane, since I plan on competing with the airplane during this season or starting next year, is that we've hid the hatch latch mechanism because the aircraft has no antennas up here. And on Dorian's airplane, you can see that he has taken the liberty of using an antenna to remove his hatch. Since the aircraft I have does not have that, we've been a little clever and we've used this little intake cooler to remove the hatch. And as you can see, when I press back, it slides back and forth. The same thing applies to the canopy. Going forward, we have a latch mechanism that allows us to gain access to interior to put in the rest of your radio gear and full cockpit, set your doors, set your retracts so that everything is in performance to a good, clean scale airplane. The aircraft also has a full flying stab that has a pivot point at 55% scale, or 55% pivot, which is for high-speed airfoil. Notice also that it has an inverted airfoil, allowing the aircraft to rotate on command. The pivot mechanism itself is recessed flush to the real aircraft. The fiberglass has a recess for this phenomenon, and this part is supplied in the kit as well as the stab. The servo location is denoted by my right hand, and when we activate it, you can see that through the hatch underneath the stab you have access also to adjust it in the field as well as to set it up on the building table. This is a very, very tight mechanism, and what helps make it real positive is that we compression load it with a wheel collar against a Teflon bearing surface that when compressed completely eliminates any radial or pivotal play, allowing a very, very tight pivot mechanism. And we need to look at a very tight mechanism at speeds where we're approaching 140 to 150 miles an hour. This is another asset about the kit that makes it nice for the modeler, is that the design has been given to him rather than having him have to create it. With the technology that we use with the A7, and with when servos are finally in place, we're going to be able to cup and make this aircraft have the same phenomenon with the fixed leading edge moving on command, and they work in unison with the flaps. The Air Force uses the inboard section, the Navy uses the outboard and the centerpiece. The outboard, of course, has not yet been added to the wing. But you can see that we have a track or a trough implanted in the wing, and using just a series of belt cranks in unison with a piece of 16th wire and some push rod connectors. And if I can get around here, when we move, maybe the best thing to do is grip it from this end. You can see that they all work in unison. Now the flap on this wing has not yet been cut out, but when the leading edge devices come down, the trailing edge flap will also be working in unison with it. They will be tied and hooked together. Again, this will be something that will be the option to the modeler, and we're not going to supply this information because of its complexity to deal with printing it and putting it into the narrative. But for the guy who's really earnest in it, we might be able to give him some help when he calls us pertaining to this.
Now, let's see what kind of flying machine this F-4 is. During this flight, Dorian has a glow plug burnout and a dead stick landing. It's always good to see how an aircraft will handle power off. This F-4, painted in fictitious marking, was created and flown for the motion picture Iron Eagle 2. It is also powered with the Turbax 3 ducted fan and the OS-65 engine. Larry has designed and built many jet aircraft over the years. Here's the F-86 kit, built as a Fury. The F-86 was intended as a trainer aircraft, easy to build and fly, with a flat-bottom airfoil and a Phillips entry on the leading edge. Larry has a love affair with the Cougar. This model has been flown as a weekend sport flyer, to FAI competition, and also in the film Deal of the Century. This 1/9 scale, 140-mile-per-hour Kafur is the only surviving model used in the movie Iron Eagle 2. The other Kafurs were destroyed with onboard explosives. These 1/10 scale F-16s were also built for the movie Iron Eagle 2. This 100% scale A-7 can be built as an Air Force D model or as a Navy E model. The detail in this A-7 is truly outstanding. This has been a sample of some of the jet aircraft Larry has created over the last 13 years. Larry tells us that he is in production on a 1/9 scale Panther intended for a 7.5 engine. If you'd like some more information on the jet hangar hobbies, kits, and accessories, their address is 12554 Centralia Road, Lakewood, California, 90715. The phone number is 213-860-7612.
Welcome back to my messy workshop for another edition of the Radio Control Sport Flyers Corner. Last time we got together, we talked about charging battery packs for electric RC flight, and it was pretty well received. We got some nice comments from some of you. Thanks very much. So we're going to talk some more about electric flight over these next 3 articles. But before we get into electrics, I want to do a little personal business here. This is probably as close as I'll ever get to being on Johnny Carson, so I want to do what all the Johnny Carson guests do. Plug a book. This is The Beginner's Guide to RC Sport Flying, by me, published by Tab Books, available at hobby shops and at bookstores like Walden and B. Dalton, also sold through the mail by Ace RC, by AMA Supply and Service, and other sources. If you are absolutely a beginner at radio control, I highly recommend this book to you for obvious reasons. That you are the person that I wrote this book for. Of course, if you're not a rank beginner, we have the Advanced Book of Radio Control Sport Flying, also published by the same company, Tab Books. In here you will find electric flight, soaring, a good-sized chapter on scale models, two-stroke engines, four-stroke engines, general maintenance, and more official AMA information regarding safety, regarding noise control. You will find an appendix with a good deal of information in it, like addresses of all the magazines, book publishers, all the rest of it. These two books were written to give you the base information that you need to continue to go out and have fun with your model airplanes. So, on to the good stuff here. In order to have a successful electric airplane, there are a few essential things. The most important thing to consider is weight. The lighter the plane, the better it will fly. This is a universal truth with any kind of airplane, but with electrics it's particularly crucial. One of the best things that's come along for electric flight in terms of making it practical and enjoyable is miniature radio control systems. We've seen a lot of systems now with mini servos. They're quite inexpensive, a lot less expensive than they used to be. And I want to take a quick look at a few of these systems. I have been flying the Kraft 3-channel KP3KB for about 5 years now. In fact, I have 3 of these systems. They came with nice small, of course Kraft is out of business now, that's the problem. But they came with nice small servos. The 3rd channel was very effective for an on-off switch. You had your 2 controls on a single stick. It has servo reversing, very good basic system. Some of these are still available from Kraft Midwest in Michigan, which does all the service on the old Kraft equipment. So if you can get one from Kraft Midwest, or if you come across one of these at a swap shop or a trade show somewhere, latch onto it, have Kraft Midwest service it. You'll have a very nice radio for electrics and sailplanes. Another radio that you might not think of right off the bat as being useful for electrics is this new one from Cox, the Cox Cadet 3. Unlike the other Cox radios, which are 2-channel, 2-stick, which is very difficult to learn on and difficult for an experienced flyer to fly with, this is a 3-channel radio with a single stick. The 3rd channel is a switch. And that makes a very nice on-off control. It has servo reversing. It's a very inexpensive system because it doesn't come with NICADs. But even with a NICAD conversion, you can get into this very, very cheaply. And the servos and receiver are nice and small. These are kind of squarish servos, the Cox Sanwa servos that come with this system. But they're very, they're not very tall, so they'll fit into a small fuselage. If you're a sailplane pilot and you're building one of these new hand-launched sailplanes like the Breedy grenade launchers or the Top Flight Aristocrat that's come out, take a look at this Cox Cadet system because those servos would fit into it beautifully. The bigger manufacturers also have very, very good equipment for electric flight for what we're dealing with. This is one of the new Airtronics Vanguard radios. The new Airtronics radios are very, very good electronically speaking. Airtronics is working more and more toward FM and everything. They feel that that's the wave of the future. And incidentally, any Airtronics radio that you have, even going back to the old gunmetal green ones, you can send it back to Airtronics and they will upgrade it to FM and supply you with a new FM double-tuned receiver that is good past 1991 and forever, and the most it'll cost you is $79.95. Some of the other radios are like $59.95. But the point is Airtronics is standing behind their products, upgrading it to bring it along with the new frequency scheme, and it's very, very good stuff. The Vanguard is a very competitively priced radio, but here's the beautiful part. These little bitty servos that they give you with it. This is the 94401 Airtronics servo. They're available as an option. You combine 3 or 4 of these servos with the Airtronics 250mm battery pack and this nice small receiver, and you have a really, really good system for electric model airplanes because it's very lightweight. You will save ounces and add minutes to your flight time. This particular system is going into my Partnavia Twin scale model. It's an Astroflight kit that is powered by 205 Cobalts, and it's aerobatic as heck. It looks like it's going to be real nice. We'll be looking at that later on. And last but far from least, the Futaba systems that are coming out now are also available with really, really small servos. This is a Futaba Conquest. Probably all of you either have one of these or you've kicked them over in the hobby shop. The very competitively priced radio, and but you might not know that you can get these with a very small receiver and very small servos. Let's see if I have one of these servos back here. Yes. This is the FPS 33 servo, indirect drive, very, very lightweight, about 3/4 of an ounce. Only one hole on each side. It's that small for the servo mounting screw. They come with an assortment of different horns, and that and their new mini receiver makes one of the nicest systems available for electric flight. Futaba has something very exciting coming along on this score too, but before we get into that, I want to show you the newest thing that Futaba has got. This is the Futaba Professor. It's an almost ready to fly electric airplane that comes with the motor, with the gear drive. ARF, I built this plane in 2 hours. Takes a little epoxy. They don't give you quite enough epoxy with the kit, so you need to have your own. But the wings are foam core, so are the tail surfaces. It's got a nice rigid structure. It's built on a wooden crutch with very lightweight plastic formed around it. And the tail, of course, epoxies directly to the wooden crutch, so you've got a nice solid setup there. This is so lightweight that you have to be a little careful. If you leave this thing in the back seat of your car on a hot sunny day, you could warp it. It's that light. This thing weighs under 2 pounds with a 6-cell 1200 milliamp battery pack in it, all set to go.
I gotta hold down.
I have one of the new Futaba systems installed in the Professor with the lightweight servos and a lightweight receiver, a 250 mil battery pack. That's part of the reason for the success. As we said, you should always go for the lightest RC equipment that you can get. Now, Futaba is coming out with something that looks very exciting for radio control electric power. It's a receiver that incorporates a speed control, so that you wouldn't need to carry an extra speed controller or a servo or some sort of a switch to turn the motor on and off. You'd have that all right in the receiver. That's got to save you a minimum of 2 or 3 ounces. And once that becomes available, I predict that a lot of electric flyers are going to latch right onto those. Because with that particular receiver and these mini servos, this has got to be a great system for electric flight. The Futaba Professor, it's a fine, fine kit. It's something that a beginner can absolutely start with and fly and enjoy. It has all the virtues of electric flights, of electric power, with none of the hazards that we've seen in some of the other things. I understand from Futaba that they will soon be importing another similar kit of a Chipmunk, semi-scale, and it should be fully aerobatic. Based on how much I like this plane, I can't wait to see the Chipmunk. So, we've had a look at almost ready to fly. Let's take a look at some of the other things that you'll need when you start getting into electric flight. Most important thing, of course, is batteries. You will find that many of the planes that are available now are designed to be used with battery packs from RC cars. These are generally 6 cells, 1200 milliamp sub-C size batteries. They're fine. They'll work. They'll work very nicely in your Goldberg Electra or in your Great Plains PT Electric or any of the other basic electric airplanes that are out there. However, you can add a minute to their flight duration by going to a 7-cell pack of 800 milliamp batteries from the 6 cells to the 7 cells. The capacity of the cells is smaller, but since you've got 7 cells, you've got more voltage, more power. You'll get it up in the air faster, turn it off, be able to glide longer. And this 7-cell pack weighs just about the same as the 6-cell pack of the larger batteries. So if you've got a Goldberg Electra or one of the other airplanes and you're getting a little tired of it and you want to hop it up, it's taught you to fly and it's been a wonderful airplane, but you're wondering what to do next, first thing to do is put a 7-cell battery pack in it. This particular pack is made by B&P Associates in Waco, Texas. And I have several of their packs. I have their kit that you bolt onto the bottom of a Sullivan starter, and it gives you a starter that you can carry around instead of having to be near a 12-volt battery or your field box. It's worked out very well for me, and these 800 mil batteries have been very, very good. I've used them extensively. Another source for aftermarket batteries that you'll find are the SR batteries. These are very famous. They are very, very high quality batteries, slightly higher in capacity than what you would call the standard. This particular battery pack is not one that you would use to power an electric flight airplane, but it's one that you might consider putting on the receiver. This is very, very miniature, very, very lightweight, weighs just over an ounce for 4 cells. It's about 100 milliamp hours, and it would power the receiver in an electric airplane quite happily for 5, 6, 7 flights, because the servos aren't working very hard anyway. So I recommend the SR batteries from personal experience. If you want to solder up your own cells, your own battery packs from individual cells, Ace RC sells all different sizes of NiCads. These are the standard Sanyo 800 milliamp red label cells that you'll read about in the articles on electric flight. So call Ace, and they have very good prices on these things. Indy RC also has a very good selection of batteries. When you ask, make sure you're looking for Sanyo red labels, because that's what a lot of the companies use, and in my experience they've been very good batteries. Aftermarket motors, if you want to hop up your Electra, the first thing you should do after you put that, okay, first you try the 7-cell battery pack. After you try the 7-cell battery pack, put an Astro Cobalt 05 in it. These are very powerful motors for their size and for their weight. The Cobalt motors have done a lot to make electric flight practical and much more exciting. This motor takes 7 cells. When you buy it, it comes with a 7-cell pack and a switch harness. You can use the switch harness or not as you please. I use them quite a bit, or sometimes I will put a micro switch in here and glue a servo to the micro switch. We'll have that set up for on-off control. So if you want to upgrade, you can go to an Astro Cobalt motor, and they're very good. But the Astro Cobalt motors have one disadvantage, or in some cases it's a disadvantage. They tend to use up their power rather quickly. They're very high performance. You can think of them as the difference between a regular engine and a Schnurly ported model engine. There are a lot of cases where in a smaller airplane, in a glider type airplane, or in an old-timer specifically, you'd prefer to have a longer motor run. So for that you should use a ferrite magnet motor. Astroflight also sells a series of ferrite magnet motors. So does Leisure Electronics, and this is the Leisure 05 gear drive setup. I've had very good success with this particular motor. It takes either 6 or 7 cells. Very happy with either one. Takes a 10-7 prop. You really don't need to experiment. Just put a 10-7 on it. The gear drive is a very neat, effective setup. You can open it up and change the gears for different gear ratios if you want to experiment. But frankly, I have had super good success with just this basic combination, and it's quite inexpensive. So the Leisure 05 system is a very, very good one for a lot of different airplanes. Okay, that gives you a little basic knowledge on motor and battery combinations. Next time we'll take a look at some of the kits that you can build to put some of these into.
Have you ever lost an aircraft due to interference or loss of battery power? We asked Cal Orr of Custom Electronics to describe the equipment he designed to keep us in the air. From there we go to Portsmouth, Virginia to check on the FAI pattern competition at the 88 Nats.
Hi, I'd like to introduce myself. My name is Cal Orr from Custom Electronics. We have quite a line of electronic accessories for radio-controlled models. I'd like to show and demonstrate some of those to you now. To start off with, we have a couple different battery chargers. This battery charger here is intended to charge an airborne battery pack, either a 4 or 5 cell pack, anywhere between 100 mil and 1000 milliamp capacity. The charger is basically a kit, comes with 4 resistors. Depending which resistor is installed in the harness, determines the charge rate of the charger. The other charger we have is a field charger intended to operate off of a 12-volt system and will charge either a transmitter and or a receiver battery pack. The charge rate on this device is selected by this switch here. In one position we get a C10, basically an overnight rate, a charge rate of 50 mils. In the other position we get a C/3, a fast charge rate of approximately 150 mils. This device I have here is what we call our Error Switch Junior. It's basically a fail-safe system, is installed in the model, plugs in between the receiver and the throttle servo. In the event of interference, loss of signal, or low battery, this device will control the throttle servo and pull it back to idle. For example, if you've had several flights in one particular day and your battery packs in the airplane fall below approximately 4.65 volts, this device will pull the throttle back to idle, essentially forcing you into a dead stick landing, while in many cases you have a couple minutes of battery power left to operate the other servos to get the model back. We have a couple different servo drivers that are basically used for installing the servos in the model for the first time, where it's not necessary to get the transmitter, receiver, and battery. Or they can also be used at the flying field to make adjustments while somebody else is on your frequency. The driver itself is powered by 4 internal N-cell batteries. Either a Duracell or a Niked kit will power the driver. Then a servo is plugged directly into the driver. When turned on, will allow you to operate the servo much as you'd be able to with your transmitter. Inside the driver we have 2 adjustments, a center adjustment and a throw adjustment, so you can match the output of the driver to that of your transmitter. Here the driver is set up for maximum servo throw. By turning the throw down, recentering the servo, we end up with minimum throw at full stick deflection. We have another servo driver, our standard servo driver, that does not have the spring-loaded center. Turn the knob clockwise to turn the driver on. The farther you turn the knob, the servo will follow. Again, it is plugged directly into a servo and will allow you to operate the servo without the use of the radio. This driver is also powered by the 4 internal N-cell batteries, and we have provided a trim adjustment, so if you use this driver with throttle, you can match the idle that this driver gives you to that of your transmitter. If this driver is used with throttle, to make things a little easier, we have our direct drive cable. This cable here is basically an electronic Y harness that's installed in the model, plugs in between the receiver and the throttle servo, where the third connector mounts to the side of the airplane. With this extension cable, you are then able to plug the servo driver into the side of the airplane to operate the throttle while your transmitter is impounded or somebody else is on your frequency. Shown over here in the display, we have the direct drive cable plugged in between the receiver and the throttle servo. Here the servo driver is plugged into the side of the airplane so we can operate the throttle without the use of the transmitter. Another device we have here is what we call the servo endpoint adjust unit. This device again is installed in the model, plugs in between the receiver and any servo, allowing you to set the limits of the servo with these 2 trim pots. This is basically the same device without the heat shrink where the wire is attached. If this device were used on landing gear, such as we have over here as the demonstration, it's plugged in between the receiver and the landing gear servo and allows me to set the limits of whatever servo I've plugged into it. This device tailors the pulse going to the servo so it will operate any servo, positive pulse servo that it's plugged into. With this trim pot here, I'm able to set the up position of the wheel, pull it back inside of the wing, and with the other trim pot, I'm able to set the down position of the wheel, pull that back more where it should go, and these are the two new limits of the servo set by the end adjust unit. This is basically a set of electronic stops. We also have our redundant radio system, which allows you to put two radios in one model for the purposes of redundancy or backup. The heart of the system is this device here we call an error switch, which is installed in your airplane and plugs into two receivers. You then plug the servos into the error switch itself. The purpose of the error switch is to sample the output of each receiver and tie all the servos to one of the receivers. In the event of interference or loss of signal on one of the receivers, the error switch will select the other. For purposes of bench testing and field testing, we have provided a selector light that lights up red when the device is using the left receiver or green when the device is using the right receiver. In this case, these two receivers are on different frequencies. This is 46 and this is channel 56. For the Futaba radio, we have this device here we call a transmitter T that plugs into the Futaba transmitter in place of the RF module. We then plug two standard Futaba modules into each side of the T, allowing the transmitter to transmit on those two frequencies at one time. We turn the transmitter on, we get needle deflection on front of the transmitter indicating RF output of the right module. The meter on the transmitter T itself indicates RF output of the module on the left-hand side. This error switch here is wired for two battery packs, one to operate the receivers and the error switch, and a second one to operate the servos. In this case, I have control of the servo from the aileron function. The selector light in this case is red, indicating we are using channel 46. Removing the 46 module from the transmitter T, the selector light changes green and I still have control of the aileron servo. Plugging the 46 module back in, then unplugging the 56 transmitter module, indicating loss of signal on 56, I still have control of the servo using channel 46. Both modules back in, transmitting on both frequencies. We then come along with a second transmitter to cause interference. Again, I still have control of the aileron servo. The selector light in this case is green, indicating channel 56. Plugging a 56 module into the interfering transmitter, we turn on. I still have control of the servo off of channel 46 because this 56 is interfering with this channel 56. Again, removing the 56 module from this transmitter, installing a 46 module, we turn on, the selector turns green indicating 56, I still have control of the aileron servo. This system here can basically be wired for 1 to 4 battery packs. We recommend at least 2 where we separate servo power from receiver power. If you have the room and can carry the weight of 4 battery packs, we have a backup battery pack for the receivers and a backup battery pack for the servos. This system is recommended for 5th scale airplanes and larger. Although it is not a crash-proof system, it will protect you from radio interference, loss of signal, component failure, or battery failure. We'd like to think that the system requires 2 problems to put a plane in the ground. I'd like to thank you for taking a couple minutes to listen to some of our products. If you'd like more information, you can call us or send for a free brochure. Our phone number is in the 714-980-4244, or you can write us at Post Office Box 1332, Alta Loma, California, 91701. Please include your phone number and address.
August 6, 1988 in Portsmouth, Virginia. We watched the last day of pattern competition at the Nationals. A very warm and humid day with just a light breeze. This year there are 202 entries in 5 categories. A record 53 contestants in FAI turnaround. The field is an auxiliary airstrip for the Norfolk Naval Air Station. The Navy uses the runway for training after dark. F-14 pilots shoot touch and goes in preparation for carrier work. This is the first year of the new FAI maneuvers. The routine is changed every 2 years. Pattern is judged with each pilot starting with 1,000 points. Judges look for errors and subtract points accordingly. Each pilot retains the 3 best flight scores, making 3,000 points the highest possible score. This is Steve Helms, one of the top U.S. competitors. Let's watch Steve perform the first several maneuvers in the FAI turnaround sequence and identify some of the things the judges are looking for. There's a lot of haze in the air. The first sequence is the takeoff and 90-degree turn away from the flight line. It's scored 0 or 10 points, all or nothing. Steve now does a procedural turn and gets ready for his free turnaround. This maneuver is not scored and gives the pilot the chance for trim adjustments. Steve's plane is smooth and stable. The vibration you see is our camera movement as we track the aircraft. Steve now goes into a square loop with half rolls. The judges are looking for constant radius with exactly 90 degrees in the corners. They're also looking for any loss of heading, and all 4 sides must be of equal distance. Steve immediately goes into a 1/2 reverse Cuban 8. He pulls up to 45 degrees. Again, the judges are looking for loss of heading or imperfections such as over-rolling. And now it's time for the 4-point roll. Steve must stop 90 degrees and hesitate for the same amount of time it takes to roll the 90 degrees. The Immelman turn brings the plane back around and Steve is set up for the reverse top hat. We're going to be looking at more of the FAI turnaround maneuvers shortly. But right now, let's go to the flight line where Ken Wells is talking to Chip Hyde.
We have Chip Hyde with us this year. He's flying in the FAI competition, and this is the last day. How are things going for you, Chip?
Well, right now, everything looks pretty good. Coming into the finals, I was in first place with a perfect score of 1,000. And I just had a really good flight, so all I need is 1 more 1,000. And we'll know in a little bit how it came out.
So the last flight you just put in was the one you felt was the best?
Right, yes. I think if anything's going to do it, that one will.
Who are you competing against really this year?
Ivan Christensen from Canada, Dave Von Linsaway, a bunch of people up at the top that aren't normally there. Steve Helms is here, Dean Koger, Mike McConville, Mike Klein, Dean Para, a bunch of people, or a lot of really talented flyers.
Who's your closest competition for that top place?
Ivan Christensen, 8 points behind me going into the finals.
8 points out of a potential how many?
1,000.
Incredible. Tell us, what aircraft are you flying this year?
This is a Larry Phillips Conquest kit, and this is the Conquest 4. And I have a YS engine in it with a Futaba radio.
Good, and how's it doing?
Great, flawlessly. The plane is working great. It's up to me now to do it.
Ivan Christensen is now in the air and beginning the reverse top hat maneuver. Ivan's airplane, like many others, is extremely quiet. At times, our microphones can't pick up the engine sound. There is a 10% bonus for a very quiet aircraft. But just to fly in the competition, the aircraft can be no louder than 98 dB at 3 meters. Ivan now goes into the 1 1/2 spin maneuver. Without letting the nose go up, the plane cleanly enters the spin, establishing a true vertical down path to show controlled recovery. Now going directly into the square horizontal 8. Here, the judges are looking for equal height and equal lengths on both squares, with the middle of the figure 8 being dead center. Now Ivan does the top hat with 1/4 rolls. This is a positioning maneuver which allows the pilot to adjust flight path position. And now the avalanche. In this maneuver, it is important to start and stop the snap roll with wings level. A 1/2 Cuban 8 brings the plane back around, and Ivan performs the triangle rolling loop. The judges are still looking for loss of heading. The beginning and end of the maneuver should be in the same place, with the roll in the center. A stall turn with 1/2 roll brings the plane back around. The next maneuver is the Cobra point roll. Ivan holds the plane in a 45-degree climb and hesitates in a knife edge without losing heading in the up or down lines. Imagine the concentration of performing a flawless maneuver while an F-14 flies low overhead. We're going to spend a few minutes talking with Ivan about the competition and his aircraft.
We're speaking with Ivan Christensen. Ivan just completed his first round and the final rounds in this competition. Wanted to know, Ivan, we just saw it was a beautiful flight, and how did it look to you?
Well, I would probably say I'd be somewhat disappointed in that particular performance. It had its real good points, and there was a couple of areas, some key areas where I erred where I usually don't and shouldn't, you know. So for those reasons, I would be a little bit disappointed maybe in it. It was generally good, but not as good as I'd like. Let's put it that way.
Is the competition getting tougher in FAI year after year?
I think I could say that it's getting tougher to stay right at the cutting edge of the competition, definitely. I'm not sure I know why, but the flying just seems to get better and better and better. And it's, you know, the equipment we're using, the airplanes that we're designing are getting fine-tuned, and you know, it's really becoming very, very sophisticated. You know, and it's tough to stay on top of it all the time, that's for sure.
Speaking of fine-tuned aircraft, why don't you tell us about the Summit?
Okay, the aircraft that we're looking at here has evolved over a number of years. You may recall, I think it was 1985, I flew the original Summit, and then along came the Summit 2, or we call the first one, to say, for the Summit 1, and then the Summit 2. Now this one has the further development of the Summit 2, and some of the basic things that we've done to this one is the lengthening of the fuselage, primarily in the tail end of the airplane, and the wing has then been moved on the fuselage. Now this being a plug-in wing configuration, it's easy enough to move the wing fore and aft on the fuselage, so when you lengthen the fuselage, the wing has to be moved to correspond with that. And so the basic thing is a lengthening of the fuselage, an increase of area, rear of center of gravity. That is, the vertical fin area has been increased by 10%, and the horizontal stabilizer has been increased from 23% of the wing area to 28% of the wing area. And what those things have done is increase the directional stability of the aircraft, which is one thing I was lacking somewhat in my original Summit 2. It was generally felt, at least, and after a lot of extensive flight testing and various opinions on the matter, it was concluded that that's what it would require.
Every pilot had to go through this check station before takeoff. Sound level of aircraft is something everyone is concerned with. Competition is a great way to bring products on the market that everyone can benefit from. Soft mounting the engine is one way to combat noise levels. We asked Ivan to tell us about the soft mount system he was using.
It's a aluminum backplate, or an aluminum plate that's bolted onto the backplate, held on with the backplate screws of the engine. And I'm using in a configuration of 3, 1, 2, 3, sort of in a triangular situation. 3 of these Lord mounts. It's not the Lord mounts that I'm using, it's a different, but it's the same kind of thing. And they're mounted between this aluminum plate, which is extended out beyond the size of the backplate of the engine, and then between it and the firewall of the aircraft, these things are sitting. And the durometer rating, with a durometer rating of 50, there's a hardness of the rubber. It doesn't require to be held in position around the nose of the engine. It seems to work very, very well. There's other things you can do as well. With that system, you also need to soft mount a tune pipe, because so the whole thing can move together. That's really the secret here. And of course, the large propellers turning lowering the RPM to in around the 10,500 mark, and long tune pipes, those are all contributing factor in lowering the noise.
Chip Hyde finished with a perfect score of 3,000 points. Ivan Christensen finished second with 2,981.044 points, less than 1% behind Chip. David Von Linsway placed third, and Michael McConville placed fourth, with Dean Kroger taking fifth. As always, competition pushed technology forward by making sound levels part of the competition. Suddenly, new products appear that help solve a basic problem. In the long run, we all benefit from those who compete and push the levels of excellence in this sport.
As you can see, if Ken Wells can hover a helicopter, anyone can. Hi, this is Ed Nakasone for RC Video Magazine. In this Breaker Blade article, we will take you to Calabasas, California to see what's new with Gorham Model Products.
This summer, we visited Gorham Model Products in Calabasas, California to get a closer look at the new Legend helicopter designed by John Gorham. This helicopter is intended to be a lightweight aerobatic ship ready for competition or sport flying. The Legend incorporates some new design concepts. The most obvious is the flybarless head. In the past, heads without flybars have had several undesirable qualities. One is a pitch roll coupling effect. Another is a sharp pitch up when you increase power, or a sharp pitch down when you reduce power. They also have required very heavy blades. John enjoyed taking on the challenge of designing a flybarless head that would overcome the bad characteristics associated with this type of head. Many months of trial and error went into development. According to John, the greatest challenge was making a head that was so accurate and free of play or slop that many problems with a flybarless head were overcome. The tail is a belt drive system designed to be simple and reliable. John incorporated a lot of flexibility into this machine with a choice of heads and tail drive systems. Or you can update your current GMP helicopter to a Legend using the flybarless head and tail rotor. Just outside the GMP plant, Robert Gorham put the new Legend through its paces. Designed to be a breakthrough, the Legend is a 9-pound aerobatic helicopter with positive and smooth handling characteristics. With a 60-size engine, the Legend is ready for sport flying or any competition. The Legend from Gorham Model Products.
Hello again from the AMA Museum in Reston, Virginia. This is Jeff Stiles. I'm Director of Public Relations at the Academy of Model Aeronautics. The 1988 NATS is over. We've all just returned from Chesapeake, Virginia, and we had a very successful time. One of the things that surfaced at the NATS in Chesapeake was a discussion concerning a permanent NATS site. Should we have one or shouldn't we have one? There was a lot of discussion, pro and con, and I'd like to throw that question out to the people who are watching this tape today. Do you think we should have a NATS site that's permanent, or do you think we should continue to rotate the NATS around the country as we have done in the past? There are a lot of good reasons to have a permanent site. It would guarantee us sufficient space for the various events that take place, and it would also give us a permanent place to store a lot of the equipment that's needed when we have a national championships. What we'd like to do is get some feedback from the membership. After all, this is a membership organization, and we need to hear what you think. The board makes the decisions, but they make those decisions based on the input they receive from the members. So we'd like to invite all of you that are watching this tape, clubs, individual members alike, to send us your comments. Get in touch with your district vice president or drop a note directly to AMA headquarters and let us have your thoughts. Another item that came up from discussions at the NATS, and this concerns me particularly because one of my jobs here is to help clubs with their flying site problems. The Executive Council is discussing a financial support program to help clubs obtain their own flying site. There are several clubs around the country that do own property. The Rams Club in New York is one example. The Toledo Weak Signals is another example. And the discussions that we've had so far center on providing some financial stability to the clubs that wish to make a loan, perhaps, to buy a piece of property. We all know that in various parts of the country, there's a lot of pressure on the use of land. Industrial and residential expansion is gobbling up flying sites, especially along the California coast and along the East Coast. So if the Academy can go ahead with this idea to maybe help underwrite a loan or some other form of financial support for clubs, then I think that could be very helpful to us in the future. From my point of view, I see that we need to get more involved in the political process, and that goes right down to the individual clubs and the individual members, so that the politicians and the elected and appointed officials who have the say over who does what on public property are aware that we exist, that your particular club exists, and that there is a need for a flying site. One thing I'd like to show you, and we put this together to help you in this program of public awareness, and it's a booklet to help clubs understand how to go about getting publicity in their own neighborhoods. It tells you how to make contact with television stations, radio stations, local newspapers, what their requirements are, what you need to feed to them, the kind of information that they like to have. So this booklet is being sent to all of the new clubs as they charter this year. You should have a copy by now if you've renewed your charter, and if you haven't, feel free to drop me a line at AMA headquarters and we'll be happy to send it to you. There's no charge for this book. It's just another service that AMA is making available to the clubs to help you do a better job out there. Thank you very much.
Here's a preview of future editions of RC Video Magazine. A lot of new-scale projects are showing up at competitions. We'll have coverage of the '88 Nationals and the Scale Master Regionals. We'll be flying down California roads in the next issue with coverage of the Great Western Race, a 21-mile course with a lot of sink and lift. If you don't make it to the finish line, just simply pick up your plane and start over. This is the year of the Tournament of Champions in Las Vegas. We bring you coverage of this high-stakes competition where the world's best RC pilots fight it out. In this new program, we're going to show practical application of many products on the market with emphasis on accessories, tools, and new products. We'll also take you to some of the trade shows and let the manufacturers introduce their latest developments. How about this half-scale Corbin Baby Ace? We were there for its first test flight. Fort Huachuca, Arizona is the head of Army Intelligence and home of the Unarmed Vehicle Platoon. One of the responsibilities of the UAV group is to train military personnel in the operation of remote piloted vehicles. In civilian terms, RC models. We're going to take a look at this operation and the kinds of aircraft the military uses. And what would life be without an occasional round of Duraplane combat? Strictly for the young at heart. If you would like a subscription to RC Video Magazine, call us at 1-800-873-3347 or send $99.95 for 4 tapes to RC Video Magazine, Post Office Box 98, Lafayette, Colorado 80026. You will receive a free special edition tape with your subscription. Thanks for joining us for this edition of RC Video Magazine. I'm Mike McLean.